Hello and welcome to this short introduction of the PARS software. PARS is an acronym for Prediction of Activity Spectra for Substances, which is exactly what the program does. It predicts qualitative bioactivity spectra for drug-like compounds based on their two-dimensional structural formulas. That's quite useful when you are at the beginning of your research and don't know much about your substances yet. Today I will show you what the free demo version of PARS looks like and how it works. We will cover the major parts of the PARS interface and basic functions. Let's start with the first window, that's this menu bar. From here you can open your SD or MOL files, edit the current SAR base, save prediction results and more. With the professional version of PARS you can also create your own SAR bases. PARS comes with a big sample SD file of known drugs containing 128 structures, but there are no restrictions to the library size. As I open the file you can see how the biological activities for all 128 structures are predicted instantly. That's how fast the underlying algorithm works. Before we get to the prediction results though, let's have a look at this new window. There are different ways to display the structure library contained in the file. This can help you to find the structure you need, provided you know what it looks like. With a right click you can also jump to a specific compound using its numbered position inside the library. For the rest of the presentation I would like to use metaxalone as example substance. I know it has the number 68, so that is where we are heading now. In this main frame we can see the two-dimensional structure of metaxalone. We can also switch the view and have a look at the M&A descriptors assigned to the structure. M&A means multi-level neighborhood of atoms, and the whole PARS functionality is based on these descriptors. They take every atom of a structure and list their neighbors, first only the direct ones and later the next level as well. Many of these M&A descriptors are included in the underlying SAR base, which consists of more than 250,000 structures and over 64,000 M&A descriptors with assigned bioactivities. Comparing our M&A descriptors to this SAR base leads to the qualitative prediction results. Those results are next on our agenda. They are displayed on the right and conveniently grouped into different categories. The General tab includes all predicted activities, while the other tabs like Effects and Toxicity only display their specific results. You can set a threshold for activities to be displayed here. PARS uses two values for that, PA and PI. PA is the probability for a structure to exhibit a certain activity, whilst PI is the exact opposite, the probability for a structure to be inactive. This means that the higher you set the PA threshold, the better are the chances that the prediction results can be confirmed in the lab. On the other hand, you might be missing out on some activity with lower probability, which your substance might still have. For now, let's choose PA to be greater than 0.5 and move on to the next great feature. As soon as I click on any of the listed activities, for example the one metaxalone is known for, the atoms of my structure will be colored. Green means that an atom affects the selected activity positively. If I scroll down the list and select the activity with the lowest probability, some atoms are colored in red. Red of course means that these atoms have a negative influence on the activity. As you can see, we also have some mixed or gray areas which indicate the possible strength of the influence. The prediction window has two more fields I would like to mention. The one below the display of the currently selected structure shows the information about this substance which is saved in the SD file. In this case it is simply the name of the structure and its position inside the library. In the lower right corner we see a field containing some general information about the current structure. There are the numbers of predicted activities within the current PA threshold. There's also the number of M&A descriptors used for probability calculation. All M&A descriptors of metaxalone are included in the SAR base. This means that the prediction results are reliable, since PARS was able to predict the bioactivities for metaxalone based on all its descriptors. Now that we have seen what PARS can do, let's imagine how you could use the software. It's good for drug repurposing because it is very easy to access a broad spectrum of possible activities. Of course, PARS also works for new compounds of which you don't have more than a structural formula yet. The feature of the colored atoms is useful if you are trying to improve a drug's effectiveness, because here you can easily change single atoms or atomic groups to see what works best with your desired activity. You can also try to get rid of unwanted side effects even before thinking about synthesis and in vitro or in vivo testing. I hope you found this video informative and interesting. If you think PARS can help you with your research, don't hesitate. Download the free demo version today.